Hi everybody. In this lesson I'm going to show you how to solve a linear system algebraically. Now there are two strategies that we're going to use for this. The first is comparison and the second is elimination. Yes! It's pretty exciting. So just watch and you'll see what happens. Now for this first example I'm just going to do comparison, and to start this off I'm going to just make up two equations and I'm going to put them both into slope-intercept form. Bam! Okay, so if I'm looking at these two equations, if I'm going to compare them, because what I'm really trying to do is I'm trying to find the point which again satisfies both equations, the crossing point. And that point has is going to have a y value and x value, and for these two equations, the y value and the x value has to be the same. So really, that means that the y's have to equal the y's. So y on the left side has to equal the y on the right side. And the x on the left side has to equal the x on the right side. So that's kind of the deal. The strategy is, look, the y's have to be the same. So that means that 2x plus 3, which was the right side of the first equation, has to equal negative 5x minus 2 in the second equation. That's kind of the deal. And so now my strategy is I want to try and I only have one variable now. I only have x. I have two x's on the left side and negative 5x's on the right side. So I want to collect all of my variables, all of my x's, onto one side of the equation, and all of my constants on the other side. So I think this is okay for most of you, but in case it's not, just watch what I'm doing. I'm going to add 5x to both sides. And so on the right side, those add to 0. On the left side, I now have 7x plus 3 equals negative 2. And if I carry on, I can, in the same way, I can subtract 3 from both sides. So I have 7x equals negative 5. And then I have x equals negative 5 divided by 7. I just divided both sides by 7. So this is the x-coordinate of my solution, but it doesn't tell me the whole story because after all, I need to know what the y value is as well. In this case, what I can do is I can take the x value and substitute it either into the first equation or I can substitute it into the second equation. It's my choice, and indeed I should get the same result no matter which way I do it. I'm going to, in this case, I'm going to substitute it into the second equation. So I'm going to write, I'll write down what I'm doing here, substitute x equals negative 5 divided by 7 into equation 2. So this is equation 2. So that means that y equals negative 5 times negative 5 over 7 minus 2. I have to be a little careful here that I don't make a mistake with my signs. So I keep on going. Y equals positive 25 divided by 7, subtract 2, and then I have to subtract 2 from 25 over 7, so y equals 11 over 7. Okay, so that means that so I can write a concluding statement, which is a good thing to do. I can say, therefore, the point of intersection, POI, is negative 5 over 7, 11 over 7. Okay? That's a good way of ending your solution. Now in this case, if you look at A, B, and C, they're all sort of formed the same way. In this case, I've written my equations in standard form. And I know that some of you are still coming to grips with standard form, and that's okay. But what I want to do, what I'm going to do in this case is I'm going to set up my equations so that I'll be able to use a process called elimination. I'm going to eliminate one of the variables, either the x or the y. And I'm going to do this, I'm going to set this up by multiplying one of the equations by a constant. Right? You're allowed to do this. You're allowed to multiply an equation by a constant number. You can't multiply by 0, that's not allowed. But you can multiply by any non-zero constant, but you have to multiply everything in the equation by the same constant. And once we accomplish that, then we'll be able to do elimination. And I'm going to go through the elimination part in the next slide. But in this slide, I just want to show you how you can multiply your equations by constants. And then in the next slide, I'll show you why you might want to do this. Okay, so if I just zoom in a little bit on the first equation, what I'm going to do here is I'm going to eliminate my x variables. Okay, now what I'm going to do in this case is I'm going to take my second equation and I'm going to multiply the entire equation by -2. Okay, I'm going to multiply the second equation by -2. So that means the first equation is going to stay the same. 4x minus 5y equals 9. The second equation, if I multiply everything by -2, I will have -4x minus 6y equals 24. Okay? Notice what I've done here. I've multiplied by a number so that the x's, the x variables have the same number in front, except that one is positive and the other is negative. So that's what I've done. This is what I know that I've done things correctly if I have the same number in front of one of the variables, x in this case, except that one is positive and the other is negative. That will make the second step of elimination a lot easier. But this is all we have to do for now. Multiply by a number, -2 in this case, so that I have the same thing happening over here. Okay, let's try one more. If I look now at the second one, what I'm going to do in this case is I see that I can multiply, I'm going to multiply the second equation. And I see that if I multiply the second equation by 3, then the y's will have the same number in front. So I'm going to multiply this one by 3. So the first equation stays the same, 6x minus 3y equals 8. The second equation, if I multiply everything by 3, becomes 12x plus 3y equals 36. And once again, I know that I've done it correctly because, or I know that I've chosen wisely here because I have the same number this time, however, in front of the y's. Okay. Pause the video now, take a look at the last one, and think, what number could you multiply by what number could you multiply to get the same coefficient in front of either the x's or the y's? I'm not gonna lie, this one is actually kind of tricky. Okay, so if you weren't sure, what you can do is you can always multiply both equations by different numbers, and that might make your life easier. So for example, what I'm going to do is I'm going to multiply my first equation by 5. I'm going to multiply my first equation by 5, and I'm going to multiply my second equation by negative 2. And watch what happens when I do that. If I multiply everything through on the first equation by 5, I get 10x plus 35y equals 95. Okay? And if I multiply the second equation through by negative 2, I get negative 10x plus 18y equals 8. Okay, so even though it looked like I was just doing extra work, I was multiplying by two different numbers, you can see that I've chosen wisely because, again, I have the same number in front of the x's. Positive 10, negative 10. So that's the first part. I'm really breaking this down in terms of steps, but the first step is when you have two equations that are in standard form, so that it's not y equals mx plus b, it's the other form, standard form, we need to, what we want to do is we want to get the same number in front of one of the variables. Okay, that's the first step. Now let's go on to the next step. Okay, so let's actually, I'm going to really put this together and put it together in terms of a problem. And I'm going to use elimination to solve this problem. Now I know that we haven't really, I haven't really shown you how to do elimination yet, but I'm going to try and put that in this context. And I find that a lot of people actually have problems setting these things up. It's mostly not because of the math, they can do the math. It's just a matter of setting up the problem correctly. So let's just read through this question here, and it says Marie paid for her $2.50 admission ticket with 13 dimes and quarters. So that means that the dimes and quarters together were 13, not 13 dimes and anyway. So how many of each coin did she use? So we don't know how many dimes she used, we don't know how many quarters she used, however we know that there were 13 coins altogether, and her ticket was $2.50. So that's what's happening there. Now, one thing that you probably were shown in grade 9 is it's valuable to write let statements, meaning you're going to define your variables. For example, we might say, we might write a sentence, let some letter represent the number of dimes, for example. So probably D for dimes. Let D be the number of dimes. And let Q be the number of quarters. So those are let statements, and I'm just going to put those in here. And there we go. So those are our let statements. Let D be the number of dimes, and let Q be the number of quarters. Okay, so we need to have our variables identified before we can even start thinking about writing equations. So now that we have our variables, let's write down the equations for this problem. Okay, so here we are. D is the number of dimes, Q is the number of quarters, and the problem says that we have 13 dimes and quarters. So that means that the number of dimes we have plus the number of quarters we have has to equal 13. That's where this first equation came from. And then, since Marie paid $2.50 for her ticket, if you know, each dime has a value of 10 cents, so 0.1, that's 10 cents, times the number of dimes, plus 0.25, because a quarter is worth 25 cents, 0.25 times the number of quarters. So those two added together have to equal $2.50. Okay. So now what I'm going to do is I'm going to show you how to use elimination in this case. What I want to do, I want you to notice one thing here. I've labeled the first equation with this little 1 in a circle. That's just to help me keep track of which equation is which. So I can say equation 1, and then you know for sure I'm talking about this one. I can say equation 2, and you can say I know I'm talking about that one. Okay, so it's just a matter of labeling things. Okay, in this case I'm going to multiply equation 2 by negative 10. I'm going to multiply equation 2 by negative 10. Okay, so equation 1 is going to stay the same. Equation 1 is just going to be D plus Q equals 13. And equation 2, once I'm going to multiply everything through by negative 10, so it's going to be negative 0.1, sorry, it's going to be negative 10 times 0.1. Well, that's negative 1 D. And 0.25 times negative 10 is negative 2.5 Q equals, and then 2.5 times negative 10 is negative 25. Okay, so again, this is equation 1, this is equation 2. Even though it's been multiplied, it doesn't matter, I haven't changed anything. And so now, here's where the magic happens. Here's where I'm going to use elimination. And this, if this doesn't blow your mind, I don't know what will. So elimination is, again, the strategy is I'm going to try to eliminate one of the variables. In this case, I'm going to eliminate the d's. And so what happens here is that because I have, these are equations here. I have equation 1 and equation 2. What I'm going to do is I'm actually going to add together equation 1 and 2 to make a new equation. Crazy, right? Watch what happens when I do. If you look here, you add down the columns. So I've written these in columns for a purpose. D minus D is 0. And Q minus 2.5Q is negative 1.5Q. Okay? And finally, 13 minus 25 is negative 12. Okay, so now that's my new equation. And you can see that it's only got one variable, the Q. The D has been eliminated, which is what I wanted to do, because this is a lot easier to solve. It's a linear equation with one variable. All I have to do is divide both sides by negative 1.5, divide by negative 1.5, and I'm going to have Q equals negative 12 divided by negative 1.5 is 8. Oops, 8. So Q equals 8. I have 8 quarters. And then I just need to go back to either one of equation 1 or equation 2. In this case, I'm going to choose equation 1 because it looks a lot simpler. And I can just substitute Q equals 8 into equation 1. Okay, so in other words, D plus 8 equals 13. So D equals 5. And then that's it. Therefore, there were 5 dimes, 8 quarters. Here's another math problem. No, not really. It's not really a problem. Okay? I hope you like that. Folks, I'll see you in class. Have a nice life.